All right, here we go. Number 41. Let's go and read it out loud. So they want the vaporization of mercury. Heat vaporization is going to be 58.5 kilojoules. They give us the entropy delta S as 92.8 joules per Kelvin, and we want to find the boiling point of mercury. So they want to know at which point does our delta G become spontaneous? Where does it become negative? Okay, where does that become negative? Well, I can't really solve for delta G when I'm solving for T as well. So I'm going to go ahead and say my cutoff for delta G, if it's going to be negative and spontaneous, if it's going to be positive, it's non-spontaneous. Let's go ahead and solve for delta G being 0. Okay, let's put that as 0. Let's make sure we put these in the correct units. We have kilojoules and we have joules. Let's change that to kilojoules. So let's go ahead and divide this by 1,000 to make that kilojoules. So I'm going to have 0.0928 kilojoules per Kelvin. All right? Let's go ahead and put that here. We have 58.5 kilojoules minus our temperature, and then we're going to have our delta S, 0.0928 kilojoules per Kelvin. Now we're going to solve for T. Let's go ahead and get T by itself. So let's go ahead and bring this over here and then divide by a negative. So we're going to have a minus 58.5 kilojoules divided by negative 0.0928 kilojoules per Kelvin equals T. I used that negative. This came over here, became a negative. Negative and negative is a positive. I'm going to get something like, let's see here, 630. My kilojoules cancel. I'm left in Kelvin right there, and that's my temperature. That's how you're going to go ahead and solve that. So when my delta G is 0, my temperature is this. So anyway, so if my temperature goes up, I'm going to make this a little bit more negative. That means I'm going to be just slightly negative on my delta G. So any temperature above this is going to make this delta G negative. All right, let's go to the next problem.